Have you ever just stopped and wondered what would happen if the planet we're standing on right now suddenly slammed on the brakes, like out of nowhere? Well, in today's Explainer, we're diving into a totally apocalyptic thought experiment. What exactly happens during a sudden 5-second stop of Earth's rotation? So, seriously, hang on tight because we're about to screech to a halt. Think about it. Would you survive if the Earth just stopped for 5 seconds? I mean, 5 seconds sounds like literally nothing, right? You can easily hold your breath for that long. It's the time it takes to fire off a quick text or take a sip of coffee. But if our planet came to an abrupt, violent, dead stop for that exact duration, the consequences would be, well, basically unimaginable. Our entire reality, everything around us, is built on the momentum of this massive spinning globe. If that momentum vanishes, even for a split second, the chain reaction of catastrophes is almost too crazy to wrap your head around. So let's break down the physics of what you'd actually experience, where you'd feel it the most, and, if there's any real hope of surviving the whole shebang.
Let's kick things off with part 1, why we spin in the first place.
Now, the Earth has been spinning for a staggering 4.6 billion years. It's this constant rhythmic rotation that literally runs our lives, right? It gives us our day and night, it drives our weather, and powers our ocean currents. But how did it actually start? Well, picture this: a massive, chaotic, swirling disk of gas and dust rotating around a brand new baby sun. As all those tiny dust and rock grains violently crashed together and clumped up to form our Earth, they generated this immense angular momentum. Those billions of ancient cosmic collisions essentially set our planet spinning in one unified direction. And here's the kicker: because the Earth is just floating out there in the vast vacuum of space, there is practically zero atmospheric friction to slow us down. That very first kinetic push from the dawn of the solar system, it's still powering our daily spin today.
It's kind of like a classic figure skater gracefully spinning on the ice. You know how when the skater pulls their arms in really tight to their body, they conserve their angular momentum and spin faster and faster? Well, the Earth actually formed in a super similar way. It pulled all that space material inward under the massive force of gravity, permanently locking in that rotational energy. And because there are basically no opposing forces out in the empty void of space to hit the brakes, our momentum is conserved perfectly. So much like that figure skater effortlessly gliding around without any drag, our planet just keeps on rotating. It is this incredibly delicate ancient balance of physics that we completely take for granted every single day. And honestly, it's a momentum we're going to ride for billions of years.
Okay, fast forward to part 2, the supersonic windstorm. Let's pull that brake.
So, what actually goes down during our 5-second emergency stop? Well, the Earth's rocky surface might stop on a dime, but the atmosphere wrapped all around it, yeah, that absolutely would not. Anything and everything not rigidly glued to the deep bedrock would violently keep moving at the exact speed the Earth was just rotating. And down at the equator, the Earth rotates at its absolute fastest. If you happen to be standing there when those planetary brakes are pulled, you would instantly be hit by a wall of wind traveling at 1,670 kilometers per hour. Just let that terrifying number sink in for a second. That is significantly faster than the speed of sound. We are talking about a supersonic blast of air moving faster than a bullet fired from a handgun, instantly sweeping across the entire landscape.
And we aren't just talking about a heavy gale that knocks you off your feet. A supersonic blast of this magnitude would be strong enough to literally tear the Earth's crust right off the mantle. Forget about surviving out in the open. It wouldn't even matter if you were hiding inside a deeply reinforced solid steel and concrete bunker. The sheer friction and extreme atmospheric pressure would obliterate urban centers, entire forests, and even mountainsides into unrecognizable dust. To truly put this level of destruction into perspective, these winds are 3 times stronger than the absolute most extreme, devastating storms humanity has ever recorded. It's a kinetic force that doesn't just, blow the roof off a house. It pulverizes entire cities in a fraction of a second. Now, you might be thinking to yourself, well, I live far away from the equator, so I'm totally safe, right? Not exactly. The geometry of a spinning sphere really doesn't offer much of a lifeline here. Basically, the closer you are to the poles, which act as the axis of rotation, the less distance the Earth actually has to travel in a 24-hour period. That means the rotational speed, and therefore the wind speed when everything stops, is slightly lower. So sure, if you're chilling in mid-latitude regions like France or New Zealand, you'd experience quote-unquote weaker winds. But don't let the word weaker fool you. You'd still face a completely catastrophic blast traveling at 1,180 kilometers per hour. That is still vastly more powerful than any Category 5 hurricane or F5 tornado in recorded history, easily tearing apart any single structure in its path. With winds that crazy, you might honestly think this supersonic, planet-wide blast would just launch you straight out into outer space. But ironically, you wouldn't actually leave the atmosphere. Why? Well, it comes down to escape velocity. That's the exact speed required to break completely free from Earth's gravitational pull. And for our planet, it sits at roughly 40,000 kilometers per hour. So even down at the equator, those apocalyptic 1,670 kilometer per hour winds are nowhere near fast enough to overcome gravity. So while you, the crumbled crust, and trillions of tons of debris would absolutely be sent flying incredible distances at the speed of sound, gravity is inevitably going to pull it all right back down to the surface. Moving right along to part 3, tsunamis and the bulge, because the wind is only half the problem. While gravity keeps all that flying debris painfully grounded, the wind is definitely not the only catastrophe you need to keep an eye out for. See, our planet, as it spins right now, isn't actually a perfect sphere. It bulges outward around the middle near the equator, pushed out entirely by the immense centrifugal forces generated by its rapid rotation. If the Earth's rotation suddenly stops, that invisible centrifugal force vanishes in a millisecond. And without it, the solid Earth and the oceans undergo a massive, rapid transformation. The planet snaps right into a perfect spherical shape. And without that equatorial bulge holding the massive oceans in place, trillions of gallons of water would immediately migrate away from the equator, rushing out toward the poles. This generates a towering, continent-swallowing tsunami traveling in 2 separate directions. Talk about a bad day. But wait, it gets worse. Let's look at part 4, the 5-second restart. So just as that unimaginable wave of ocean water is violently rushing poleward, literally tearing across continents, our 5 seconds are up. Remember, this thought experiment demands that the planet violently snaps back to its full rotational speed. And this brings us to the devastating double tap. The moment the Earth spins up again, that invisible centrifugal force immediately returns, and the planet bulges back out at the equator. So all that displaced water that just rushed toward the poles, it would instantly backtrack. A towering wall of displaced ocean would reverse direction with unbelievable kinetic energy and slam back toward the equator, meaning a mega tsunami would smash into the planet's remaining land masses and whatever is left standing a second time, basically scouring the Earth completely clean. Which brings us to the final, grim question in part 5, how to survive. So after surviving the supersonic gales and a literal global double tsunami, what does the grim aftermath actually look like? Well, if you happen to be standing exactly at the North or South Pole when the brakes are pulled, you might actually survive the initial winds. Because those points act as the exact axis of rotation, lateral movement there is practically zero. That makes the poles the only relatively safe zones from the initial atmospheric blast. But for the billions of us everywhere else on the globe, the brute force of those winds and that water is flat out unsurvivable. Once the Earth returned to normal, our modern world would simply cease to exist. Every city, all our agricultural farmland, the entirety of our technological infrastructure, completely demolished beyond recognition. So what is the ultimate, incredibly dark takeaway for anyone hoping to survive the sheer brute force of this apocalyptic scenario? Look, if you don't happen to live precisely on the North or South Pole, your only real option is to start digging, like right now. A deep, highly reinforced underground bunker is effectively your only real shield against crust-tearing supersonic winds and back-to-back mega tsunamis continuously scouring the surface. You'd seriously need to be buried deep enough into the solid bedrock just to avoid being ripped up by the atmospheric friction, and packed with enough supplies to outlast the total, absolute destruction of the biosphere above you. Okay, take a deep breath. You'll be super relieved to know that the strict laws of physics dictate the Earth won't be coming to a screeching halt anytime in the next few billion years. We are safe. In fact, long before our planet's rotation could naturally slow to a dead stop, our sun is scheduled to exhaust its fuel and violently expand into a red giant, which honestly is a way more pressing cosmic hazard to prepare for. But while our planet's rotation is relatively stable for now, this whole wild thought experiment does leave you wondering, if our world is built on such a delicate balance of physics, what other invisible cosmic timers are silently ticking away right over our heads, just waiting to hit zero?